Welcome. Now we'll discuss solar thermal power plant. Solar energy is a renewable energy, and the world is currently undergoing irreversible climatic change due to the effect of global warming arising from the massive production and consumption of fossil fuels. Among the alternate energy sources, renewable energy sources have a huge potential to meet the energy requirement and mitigate the climate change impacts. The global renewable energy installed capacity was 921 gigawatt in 2017, and India's share was around 70 gigawatt. We have abundant natural resources such as solar power, wind power, bioenergy, and hydropower. Government of India has set an ambitious target of achieving 175 gigawatt of renewable energy by 2022. This target comprises of 100 gigawatt solar power, 60 gigawatt wind power, 10 gigawatt bioenergy, 5 gigawatt small hydropower. The target is to achieve 20% share of renewable energy in its total electricity consumption by 2022. So renewable energy resource chart is shown here. We have renewable energies like solar energy, wind energy, hydro energy, and bioenergy. In solar energy, we have different devices, technology to harness the solar energy. Flat plate collector, evacuated tube collector, concentrated solar power, and solar PV. So in this video, we will not discuss solar PV. Then in wind energy, we have onshore wind energy and offshore. Then hydro energy, runoff river, pumped storage type, small hydro. Bioenergy include bioenergy for electrical and heat, and biofuels from the seeds. So in this video, we'll discuss solar thermal power plant. So power plant operated by solar energy using thermal mode. So here, typical potential of various renewable energy and installed capacity in India is shown. So first, renewable resource is wind power. At 100 meters, we have 3,02,251 megawatt is the potential. At 80 meter, we have 1,207,788 megawatt potential. And for 50 meter, we have wind energy potential of 49,130 megawatt. And the installed capacity of wind power plant in India now is 34,193 megawatt. Second is solar power, ground mounted, having potential 50 megawatt per square kilometer. Okay, in India, we have good sunshine in India, so we have good the potential of solar energy, 50 megawatt per square kilometer, and the installed capacity is 21,118.64 megawatt. Solar power rooftop PV mode installed capacity 1,210.75 megawatt. Then we have another renewable energy source is biomass power and bagasse cogeneration. So we have potential is 23,700 megawatt and installed capacity is 9,375.61 megawatt. Then we have small hydro up to 25 megawatt having potential 15,000 megawatt, and the install is 4,493.2 megawatt. Then tidal and wave as a renewable energy source. Tidal having potential 8,000 to 9,000 megawatt, and wave 40,000 megawatt. Then ocean thermal energy conversion called as OTEC, having potential 1,80,000 megawatt, and geothermal having 10,000 megawatt. So this slide shows the potential of various renewable energy and install capacity in India. Now, introduction to solar energy. Our focus in this video is on solar thermal power plant. Sun is the main source of energy, and all other renewable sources are derived from the sun energy. Heat is produced in the sun by fusion of two deuterium atoms to form a one helium and huge heat. And this energy radiated by sun is about 3.7 into 10 raised to 20 megawatt. Energy issued on Earth's surface by electromagnetic waves or in the form of teeny particle called as photon is 1.85 into 10 raised to 11 megawatt. And potential of solar energy is 30 to 40 megawatt per square kilometer. We have advantage for solar energy that solar energy is a renewable form, inexhaustible, freely available, and it does not produce any form of pollution, and used to produce thermal energy by which the steam is generated, and that steam is used in Rankine cycle to produce electricity, or by using photovoltaic conversion, we can generate electricity directly by using solar energy. There are few difficulties associated with solar energy. And the first difficulty is solar energy source available is dilute, and it is typically 1 kilowatt per square meter. And it is not available continuously, it available intermittent, okay, and typically available for 8 to 10 hours per day. And there is seasonal variation also. So solar radiation are available more in summer and less in rainy season, and less solar energy is available in cloudy day. Types of solar thermal power plant. We have three types based on temperature. Low temperature solar thermal power plant using flat plate collector. Operating temperature is 60 degrees Celsius to 100 degrees Celsius, and efficiency is low because of low temperature, 3 to 5%. Then medium temperature solar power plant using concentrated solar collectors, and the operating temperature range is 250 to 400 degrees Celsius. Then third category is high temperature solar power plant using tower system or parabolic dish collector, and having operating temperature in the range of 500 to 700 degrees Celsius. In low temperature solar thermal power plant, the devices used to collect solar radiation is flat plate collector based solar water, that is also used for solar water heater. Okay, and that heat is used to produce the vapor from the low temperature fluid. So in this picture, we have flat plate collector is shown, and the flat plate collector consisting of metallic box. Then we have glass sheet over the box. Then we have the absorber tube. These are the absorber tubes fitted between the two headers, the upper header and lower header. And these tubes are black coated to absorb maximum heat. So solar radiation falls on this glass sheet and then transmitted inside and incident on these black tubes in which water is flowing. So that heat is absorbed by the water. So main components, we have solar collector, flat plate collector, then cold water tank, insulated hot water storage tank, okay, for the water heater as well as for the low temperature power plant. So component of flat plate collector consisting of the inlet header, then we have lower header from which we have outlet, then glass sheet, then this is the aluminum box, then we have absorber, below absorber is insulation at the bottom and at the side to avoid the heat loss. And for solar water heater, natural circulation thermosiphon having capacity 100 to 2000 liters per day. And for forced circulation system uses pump in higher capacity. A typical 100 liter insulated tank with 2 meter square collector area can supply water at temperature 60 to 80 degrees Celsius. System is domestic and used for 3 to 4 members in home. A bank of collector can be arranged in series and parallel combination to get higher quantity of hot water, and that hot water is used to generate vapor from low temperature working fluid in low temperature power plant, and also used to heat the water, which is used as a feed water for the boiler. This is another type of collector, evacuated tube collector, consisting of the lower header and upper header. Between them, we have the evacuated tubes, and the water is flowing through that evacuated tube. So solar radiation falling on this tube are get absorbed by the water flowing through the small tube inside the evacuated cover. And due to evacuated tubes, heat loss decreases and efficiency is higher. Evacuated tube collector based solar water heater. Evacuated tube collector consisting of parallel rows of tubes, which we have seen in the picture. The tubes are made up of double layer borosilicate glass tubes evacuated for reducing heat losses. The concentric tube arrangement is used, and through inside tube water is flowing and the annular space is evacuated to avoid the convection heat losses. And the inner tube is coated with selective absorbing material to enhance heat transfer absorption. Evacuated tube collector produce high temperature up to 177 degrees Celsius, more than the flat plate collector. The evacuated tube collector achieves higher efficiency at higher temperature. The collector area required for system is 1.3 square meter for 10,000 LPD. In case of flat plate collector, we require here 2 square per meter. Industrial application include preheating of boiler feed water, cooking dish washing in industrial canteen, washing of milk cans in dairies, sterilization of surgical instruments. So the hot water generated in flat plate collector and evacuated tube collector is also used for the low temperature thermal power plant. And by using this heated water in flat plate collector and evacuated tube collector is used to produce vapor from the low temperature working fluid like refrigerant or freon, and that vapors are used in Rankine cycle to generate electricity. So this is typical schematic of low temperature solar power plant using flat plate collector. So here we have area of flat plate collector, and we have already discussed the structure of flat plate collector and the component. So here number of flat plate collectors are arranged in series and parallel to get the more flow rate. Array of solar water flat plate collector, solar radiation falling on it. The water is heated. That heated water enter into this heat exchanger called as butane boiler. So hot water exchange heat to the butane, and butane evaporate, form a butane vapors, and the water from heat exchanger is again pumped to solar flat plate collector by this circulating pump, and the vapor form, butane vapor form, are passed to the butane turbine, where it drive the generator, and the expanded vapors are then passed to condenser, where it condenses, and the condensed butane again supply into this boiler with the help of this feed pump. So typically low boiling temperature work include refrigerant like R11, butane. So typically, suppose the high temperature in a low temperature application, low temperature solar thermal power plant using flat plate collector is 60 in Kelvin, 333 Kelvin, and lower temperature in the cycle is T2 25 degrees Celsius, 298 Kelvin. Then Carnot efficiency is T1 minus T2 upon T1. Okay, so T1 is 333K minus 298 upon 333. So what is this ratio? 0.105. In percentage, 10.5% is the Carnot efficiency. Now, typically flat plate collector at 60 degree, the efficiency is 50%. So efficiency of the overall efficiency of the low temperature solar thermal power plant is 0.5 into the Rankine cyclic Carnot efficiency. 0.5 into 0.105, that is 0.0525, means 5.25% is the efficiency of low temperature solar thermal power plant. So efficiency is very low because the temperature range is low. Another low temperature solar thermal power plant is solar pond. So in this case, we have here pond, okay, in which we have the brine water and solar radiation falling on the brine water is get heated. Boiling water of brine water increases, so temperature increases, and also brine water evaporate less. Okay, so heat is stored in the water and water is get heated. This heated water is passed into this heat exchanger, and that hot water exchange heat, hot brine water exchange heat to the refrigerant 11, and the vapor of refrigerant 11 are formed, and the hot brine again become cold by rejecting heat and flows to the solar pond by that thermosiphon principle. And the vapor refrigerant enter into turbine where it expand and operate turbine. Turbine is coupled to generator, so generator is get rotated and electricity is generated, and the vapors from the turbine exhaust goes to the that condenser where it condenses, and the condensate is again pumped to the heat exchanger with the help of this pump. So in this way, solar pond electric power plant works, and it is low temperature solar thermal power plant. Concentrated solar power, okay, which is used for the medium temperature solar thermal power plant. In this system, direct solar radiation are concentrated and focused on a receiver to obtain higher temperature up to 800 degrees Celsius. The temperature to be obtained depend upon concentration ratio of concentrator. This system requires tracking system so that the reflectors follow the sun. Solar concentrators include parabolic dish collector, linear parabolic trough collector, and linear Fresnel collectors. These are the concentrators. Parabolic trough collector called as PTC. Okay. So this is parabolic trough collector, which consisting of this parabolic collector over which the reflected surface is provided, and all solar radiation falls in this parabolic trough collector or get reflected on this pipe, okay, which is pipe receiver, and it is coated with a black coating. So all radiation reflected from the receiver are absorbed by the working fluid flowing through this pipe. If water is flowing, water absorbs that heat. If oil is there, oil absorbs the heat. So here is fluid in, at the other end we have fluid out. And this is the typical parabolic trough collector, which consisting of receiver. Then this is the reflector. So solar radiation falls on reflector and reflect at the receiver. And we have this collector is mounted on the tracking system. So tracking system operate this collector in such a way that it is facing the sun. So parabolic trough collector is the most mature among the CSP technologies. The direct radiation falling perpendicular to the parabolically curved trough shaped mirror is reflected and concentrated on absorber pipe located in the length of the focal line. Heat from the absorber pipe is removed by circulating heat transfer fluid through the pipe and is utilized to produce electricity or process heat. PTC is normally tracked in single axis and oriented in north-south direction for good energy yield. Concentration ratio up to 80 is obtained, and heat transfer fluid can be heated up to 550 degrees Celsius. And it is practically achievable temperature, and the application include industrial and commercial scale power generation or cogeneration, solar cooking, milk pasteurization, boiler feed water heating, and other application of steam. So this is parabolic trough collector. So this parabolic collector is used in array, means number of parabolic collectors are connected in series and parallel to increase the capacity to get the more hot water, and that hot water or hot oil, and that fluid heated in the array of parabolic collector, okay, is a store in the storage tank. And from the storage tank, the working fluid is passed to the heat exchanger or steam generator, where it exchange heat to the water, and water is evaporated into steam, and that steam flows to the steam turbine, and the working fluid flows return to the storage tank, and the steam entered in the steam turbine expand over the moving and fixed blade and rotate the shaft of steam turbine, which is coupled to generator, and generator is get operated and generate electricity, and the expanded steam leave the steam turbine and enter into condenser, where it condenses by rejecting heat to cooling water, and the condensate form is again pumped to the heat steam generated with the help of feed pump. And such typical power plant which uses parabolic collector for collecting heat is in Rajasthan and having its capacity 30 megawatt. Another collector is the parabolic solar dish collector. See, we have very large size dish, okay, and the radiation falling on this dish are reflected at the center, means on the receiver. And the previous collector we have discussed reflect the radiation on pipe, means on the line, so called as line focusing. And this is reflect the solar radiation at a single point, okay. So all radiation falling on this collector are reflected at the single point where receiver is located. And so this collector is called as point focus collector. So solar radiation falls on this large dish and get reflected on the receiver. And in the receiver, we have oil, working fluid is flowing, which take that heat. So parabolic solar dish collector consisting of parabolic reflector dish, heat absorber or receiver. The solar dish collector can consisting of flat mirrors attached to steel or aluminum frames, and tracking system is provided to follow the sun by the collector. The focus beam of intense solar energy generate heat due to the very high temperature at the focal point. A thermal oil type fluid is generally used instead of water inside the absorber. The heat absorber can be as simple as small air-coated tube or more complex solar heat engine, such as Stirling engine can also be directly used there to produce electricity instead of heating the oil at focal point. Instead of receiver, here we have this is collector and this is receiver. So instead of this receiver, we can use Stirling engine and we get electricity directly out. And in case of receiver, we are heating oil, and that heated oil is used in heat exchanger to generate steam. Design popularized in India include Shepler dish and around 160 dish, a two-way tracking parabolic dish with an aperture area of 160 meters square, weighing around 20 tons and generating 120 kg of steam per hour. That is 80 to 100 kilowatt of thermal output. So this is the clear picture of parabolic solar dish collector. So this can be used to produce. So this is the reflector. When radiation falling on this reflector, all radiations are reflected at a focal point where receiver is located, and that receiver consisting of coil through which oil is flowing. So oil is get heated, which is stored in storage tank and then used to generate steam in steam generator, or directly Stirling engine is used at focal point, and Stirling engine which operate generator, and we are getting directly electricity from this parabolic solar dish collector. High temperature solar power plant using dish collector, which we have discussed. Heatless quantity of fluid. So Stirling cycle is used to generate electricity. System working at Hyderabad of capacity 30 kilowatt with efficiency of 30% is Stirling cycle type. This collector can be connected in series and parallel to increase temperature and flow rate. not suitable for large power plant. Now we have the high temperature power plant, third type, which is power tower. In this central power receiver power plant, which is high temperature power plant, we have in a large area, heliostat are there, and all solar radiation falling on heliostat spread in around the tower reflect the solar radiation on the boiler or receiver of the tower. And means thousands of heliostats are there around the tower. And at the top of the tower, we have receiver, and all heliostats reflect solar radiation falling on them at receiver. And in the receiver or boiler, the heat is absorbed by the water and the steam is generated. As this receiver is fixed on the top of the tower, it is not moving, so we can directly produce steam. In case of parabolic collector or parabolic dish type collector having a tracking system, it is following the sun and it is moving, so we cannot generate steam in the moving part according to Indian boiler regulations, IBR. But in central power receiver, this tower is fixed and receiver is also fixed, it is not moving, but heliostat is tracking and follow the sun and reflect solar radiation always on the receiver. And directly steam is converted into heat, that water is converted into steam, and that steam is used in steam turbine to generate power, and that mechanical power is converted into electricity by using generator, and the steam expanded is enter into condenser where it condenses by rejecting heat to cooling water, and again the condensate is pumped into boiler with the help of this feed pump. So this is about the central power receiver power plant, which is high temperature power plant. So this configuration uses 100 or 1000 of flat mirror called as heliostat and to focus and concentrate the sunlight on a central fixed receiver. Due to the use of large number of reflectors and high level of concentration, very high temperature, about 550 degrees Celsius is achieved. The working fluid that receives all this heat can be water, high specific heat capacity, or molten salt. Steam generated is used in steam power plant. The efficiency level is similar to that achieved with thermal power plant. Application: solar cooling, industrial processes, power plant. So this is another picture of same central tower receiver power plant. We have the sun radiation falling on the heliostat, which are around the tower, and this heliostat reflects solar energy on the receiver. In the receiver, oil is flowing in this case, and that oil is heated and stored in this tank, and that heated oil is passed into steam generator where it generates steam and then cool oil enter here and then again flow into receiver, and the generated steam is passed into steam turbine, and steam turbine rotate, which rotate generator, and electricity generated is passed to the consumer, and here the expanded steam passed to the condenser where it condenses and again passed to steam generator. The last power plant, solar thermal type is solar chimney power plant. So in this case, see, we have, this is the chimney type structure, and this is the transparent cover. Okay, and below this chimney structure, we have here the turbine, gas turbine, and to the air turbine, here electric generator is coupled. Now, when solar radiations falling on this transparent cover, it transfer heat inside, and this air inside this under this cover is get heated, and it flows up, and its place is taken by cold air surrounding this plant, enter into this plant and flows under this cover. Again, it is get heated, become light, flows off, and this is high-tide chimney. So here the pressure exerted by this hot air column is low compared to the outside air. So the air is flowing with some velocity, reasonable velocity through the chimney, because air is warm, and that flowing air rotate this air turbine, and to which generator is coupled, and generator generate electricity. So this is solar chimney power plant. So in this video, we have discussed the solar thermal power plant, in which we have discussed the three type: low, medium, and high temperature solar thermal power plant. Thank you.